Linux and Unix operating systems certainly allow us to do things from the command line, but also in some cases with GUI interfaces. In this video, we'll explore Linux command line OS monitoring tools. There are plenty of tools built into Linux that we can use to monitor various aspects of the system. The first one we'll take a look at here is top. Now remember that Linux commands are case sensitive, so where I'm typing this in lowercase letters actually matters. Now when I type in top and press enter, I get a list of running processes where the top users of things like CPU utilization are listed at the top of the list, and the ones that are putting the least amount of load on the percent CPU utilization are listed further down the list. So notably, we can see the PID in the leftmost column, the process ID, followed by the user that spawned that process. Now in some cases, the system itself will spawn processes. Further over to the right, we can see the percent of CPU utilization and percent memory being consumed by a given running process, along with the actual command itself listed in the rightmost column. There are also some statistics up at the top, like how long the system has been up and running, how many users are connected, the load averages over the last periods of time. It tells me that there are 207 tasks running in total, and so on. But we can interact with this while we're working with it. For example, if I press the letter D, I get asked to change the delay from the screen output from this command from 3 seconds to something else. Maybe I'll type 0.5 and press enter. And we can immediately see that our update is much more frequent. I'm going to press D, and we're going to go back to every 3 seconds. So I'll type in 3 and press enter. But there are other great things we can do here in top as well. For instance, maybe we don't want to see all of these columns of information. We're only interested in a few. So how do we filter them out? If I press the letter F, and of course I'm not holding shift, so it's not an uppercase F, it's just a regular lowercase f, it takes me into this screen where I can manage fields. So F for fields. In the left-hand column, we can see whether or not there's an asterisk next to a field name, and if there is an asterisk, it's currently being displayed. So basically, if you use the arrow keys to move up and down, and you can toggle the display of a field on and off by using your spacebar. So if I hit the spacebar for a bunch of these fields I don't want to see, then the asterisk is removed, which means that they will not appear in the screen output. And maybe I want to sort by something other than CPU utilization, maybe by %mem for memory. So I'll go down with my arrow keys and highlight that one, and then what I can do is press the letter S to sort by that. Now you might say nothing changed on the screen, when in fact it did if you look in the upper right. It says the current sort field is %mem. You see, if I highlight %CPU and press S, now up in the upper right it says current field that is being sorted is %CPU. So I'm going to go back and sort it by memory. Now that I'm happy with this, I'll press the letter Q for quit, and we're back in the top command where we still have a live updating changing screen every 3 seconds. However, we're missing some columns, and now it's sorted by %memory instead of %CPU. So I'm going to go ahead and press Q to quit out of here. In Unix and Linux, we have manual or man pages, which are help pages for Linux commands. So maybe I want to know more about how to use the top command, maybe in batch mode where I can start writing things to files instead of having to babysit it in real time while I watch it on the screen. So for instance, if I were to type man space top, it opens up the man page for the top command. And as I go further down, I'm just pressing the enter key here. As I go further down through this man page, I can see all of the different ways that this command is designed to work. And eventually, as I go further down, I'll see the various command line switches, such as -b, to run in batch mode. Now, the idea here is batch mode can send output, for instance, to a file, so we can examine our monitoring through a file instead of having to view it in real time. So I'm going to go ahead and press Q to get out of that man page. Now, some other interesting commands in Linux, and there are plenty of them, include things like the PS command to list processes. When I type PS with no parameters, it only shows me the running processes in this current session. So we've got our bash Linux shell, which is allowing us to type things in the first place. And of course, at the time it was executing, PS was executing, so it shows up as well. We can also see the process ID assigned to each of these processes in the leftmost column. However, things get interesting if I start using command line switches like AUX to view all processes, including user processes, and the X is for processes are tied to a terminal. That means things that are started up by the system. So if I do that, I get a very big output. Now, of course, I'll use that arrow key to bring that back. I could pipe that using my vertical pipe symbol, which I get by shifting the backslash key. I can pipe that to more to stop after the first screen full. This way I can see the column headings at the top. So from the left, we've got the user column followed by the process identifier, %CPU, %memory, and so on. In Unix and Linux, we could also pipe the result of a command like psaux to grep, where we might filter for something specific. Here, I want to get information about the running process called SSHD, the SSH daemon, which allows remote command line administration. And in this case, I can see that I've got a couple of entries. Ignore the last one, which of course is us grepping for SSHD in the first place. But I do see the first listing here where it's referencing my SSH daemon, which is running on this host. So if we want to, we can filter those types of things out. Also in Linux, other interesting things we can do, for instance, at the disk level, is we might use df or disk free. Now, what I might want to do, instead of viewing this in 1K blocks, is use df-h for human readable. Then instead, it's a little bit more readable where I'm reading the megabytes, or technically the mebibytes. And the difference really is that a megabyte is 1,000 kilobytes, where a mebibyte, and yes, that's what I said, mebibyte, is actually 1,024 kilobytes. So there is a little bit of a difference in how some Linux distributions will display things. And technically a mebibyte is not exactly the same thing as a megabyte. Other things I might be interested in using for monitoring here, built into most Unix and Linux distros, is the TCP dump command. This one is really cool because it's kind of like having a built-in command line packet sniffer, and it's been there for decades. For instance, if I type TCP dump-I for interface, now that's a lowercase I, remember case sensitivity is important. I'll give it the name of my interface, which I know is eth0. If you're not sure, you can type ifconfig on your Unix or Linux host. If I just press enter, it's capturing everything and it's scrolling by very quickly. So I'm going to interrupt that by pressing Control-C, and I'll type clear to clear my screen. I'll use the up arrow to bring up TCP dump command. What I want to do here is capture traffic destined for a specific host. So I'll put in the IP address here where it's going to port 22. So DST for destination, followed by a space and the destination IP. Then after that, we've got a space, the word and, a space, the word port, and a space and 22. So I only want to capture stuff going to that IP address specifically to port 22. And I can also pass it -A to view everything in ASCII form instead of hex. So now we can see SSH traffic that applies to that specific type of connection that we asked for. I'll press Control-C to interrupt it. Last thing we'll mention about TCP dump is you might want to write that stuff to a file. So I'll just bring up our previous command and I'll add another switch after a space. What I'm going to add is -w, which means write. And I'm going to put that in a file called, let's see, capture1, let's say, .cap. Okay, so now I can see TCP dump is listening. Normally we would see, in this case, SSH traffic. We're not seeing it because instead it's being redirected to our .cap file. This can be useful because you could let this run for periods of time. You could even schedule it as a cron job in Unix or Linux, and then review the reports of what's been captured at some point in the future. I'm going to go ahead and press Control-C to stop the capture. It tells me a few packets were captured. Finally, I could use TCP dump-r to read in that file, capture1.cap. And there's the data that was captured. In this video, we talked about Linux OS monitoring tools.